Hello students, in this video we are going to learn about programmable logic array PLA. In our previous video we learned about ASIC. We saw about semi-custom design, full custom design and different types of semi-custom design also. Now we shall see about the programmable ASIC, which is nothing but programmable logic devices. So in programmable logic devices, there will be certain classification, and the first one is nothing but your programmable logic array PLA. The name itself says that your logic array can be programmed. So you can program your devices such that there will be an array of gates and you can program according to your own specification. See, it is a programmable device which is used to implement the combinational logic circuits. So whatever the logic circuits you have, I can program my device such that I can implement my combination logic circuits. The thing that you must not forget in the programmable logic array is it will be having a set of programmable AND array and a set of programmable OR array. Means you can just do the modification or you can program your AND array, and at the same time you can program your OR array also. If there are n inputs, you will be having m outputs. See, the PLA has a set of programmable AND planes which link to a set of programmable OR planes which can then be conditionally complemented to produce an output. So the thing you must not forget in your PLA is there will be a programmable AND as well as a programmable OR array. So in examination point of view, you may get a question like implement a function using PLA. So immediately on seeing PLA, you must remember that my both AND array as well as OR array are programmed or programmable. See, AND array is nothing but there will be a set of AND gates. OR array is nothing but there will be a set of OR gates. You can program your AND gates, you can program your OR gates. We will see what is that programmable. Okay, because I'm keeping on saying my AND array is programmable and OR array is programmable. We shall see through the example. Only then it will be easy to understand the PLA. PLA is so easy to understand. See, suppose the question is implement the function using PLA. What is that? Y1 and Y2 are given as your output. So you have to implement Y1. So Y1 is summation of minterms 4, 5, 6. And then Y2 is given as 3, 5, 7. So, and they have given A, B and C are your inputs and Y1 and Y2 are your outputs. So now, first step is you have to frame a Boolean expression for your function. So how many Boolean functions do we require? We require 2 Boolean expression for each of my output. So how I can find a Boolean expression from the given terms? I can do the K-map simplification and I can just write the terms and I can group it. I guess you all know what is a K-map. If you don't know, just see to the diagram. I have just framed the values. I have drawn the K-maps for the generation of Y1 and Y2. So 3 ones because 4, 5 and 7 are the minterms, and for Y2 I have 3, 5 and 7 are my minterms. So I have grouped it and I have got the values of Y1 as A B bar plus AC and Y2 as BC plus AC. So how many number of input buffers do I require? Number of input buffer is given by the number of input variables. So what is that input buffer? Input buffers are nothing. It will be a series of NOT gates. Suppose consider it is a chain of NOT gate. In that chain I will be having 2 NOT gate. Just assume I have not drawn over here. Suppose my A is coming as your input, and if it is passed through a NOT gate, you will be getting A bar as your output. Again, if I take another NOT gate. The A bar will be sending into the NOT gate, and I will be getting A as my output. So when A is passed through one inverter, I will be getting A bar. When it is passed through two inverter, I will again get the same A. So if I take output from after one inverter, that will be A bar. If I take the output after two inverter, I will be getting A. That is what I have mentioned, like not with a bubble over here. If I take the output from one inverter, I will be getting A bar, that is from the bubble. If else from the two inverter, I will be directly using that as a buffer. So one line is going to serve as a buffer, and one more line is going to serve as an inverter. So A, and then what is it? The second inverter or the second buffer that I am using, B, because I have three inputs. So A, B and C are my inputs. So I am using the three input buffer. And then what is it? Number of programmable AND gates. See, the thing is PLA. So we are going to program both your and as well as program both your OR. So now number of programmable AND gates. We want to find the number of programmable AND gates. So how many AND gates do we require in our design? That will be based on number of the minterms. So how many number of minterms are there, that many number of AND gates must be there, but make sure that min gates or minterms are not repeated. If suppose there are common minterm, just take only one minterm and don't repeat the minterm and don't write the AND gates for the extra or the same in minterm that has been repeated. So what were the minterms that was available? See here, what are the minterms? A, B bar, AC, and then BC, and again AC is there, but AC is been repeated, so I am taking just one minterm. So A, B bar, AC and BC are my minterms. So there are three minterms. So how many number of AND gates do I require? I require three AND gates. So I have just drawn three AND gates. Okay. So first draw three buffers and then draw three AND gates and just draw a straight line from the each. And then how many OR gates do I require? OR gates will be based on the number of function. If I have two function, what is the function? Y1 and Y2 being the function. So Y1 is taken from, what is Y1? Y1 is equal to A, B bar plus AC. So just draw a common line, okay? And just connect the OR gate. First we are going to frame. First the structure must be draw the buffers and just make sure how many AND gates you need and how many OR gates do you need. Now we are going to give the connection. See, for the first AND gate, what was the first minterm? The first minterm was A, B bar. So how I can take this is A and this is A bar. So A and B bar, which is A, B bar. Just put a cross and shows that there is an interconnection. Again, A and C, the second minterm. And what is the third minterm? B and C. So B and C, I have just put the interconnection and that is BC. So there are three minterms and that has been marked by three AND gates. And now we have to give for Y1 and Y2. So what is Y1? A, B bar plus AC. So I have given the connection A, B bar plus AC. And that is going to give my Y1. And what is A2? Which is AC plus BC. So it is equal to Y2. So number of AND gate will be equal to the number of minterms, whereas the number of OR gates will be equal to the number of function that we are having or the number of outputs. In simple terms, I can call it. What is it? This is nothing but a programmable logic array. We had a programmable AND gate and we had programmable OR gate. Means I had an array of AND gates and I had an array of OR gates and I did the programming such that my particular function is being implemented. That is what it is called. Programming is done on both the sides, which is on the AND side as well as the OR side, and it is going to be called as programmable logic array. This is all about programmable logic array. And in next video, we shall see about programmable logic devices in specific. Hope you understood the video. Thank you.